Hello, hello. This is Postgres FM. This is Nick from Postgres AI, and as usual, co-host Michael. Hi, Michael.
Hey, Nick.
Yeah, and we invited a couple of guests today, Nate and Andrew, and we invited because the company Metronome experienced outages in I think in May, right, or April, in May, right, in May of 2025, which were extremely hard to diagnose, but these folks did very good job and discussed all the details in excellent blog post. And this blog post looked so great, so we couldn't miss it. So thank you for coming. Let's dive into some very rare Postgres problems.
Yeah, thanks for having us, and hopefully sharing this out will keep making it rare.
Yeah.
Yes, thank you for having us. It's a pleasure to be here.
Great. So, Michael, where should we start?
How about we start with, could you guys give us a little bit of an overview of what Metronome does, why you're using Postgres, and what you were up to that was hitting the limits this hard?
Yeah, so I can start with the overview, and then Andrew and I can pair on the exact way that we kind of blew our foot off here.
Absolutely.
But yeah, so Metronome is a usage-based billing platform. And so, when it was founded, I think it's coming up on 6 years ago now, it was really, at that point in time, this is just before COVID and lockdowns began. The target was really, there's a lot of infrastructure as a service companies. Most of them are billing on some kind of heartbeat, per minute or sometimes per second model. That gets really tricky to do at scale. In the simplest cases, you're just incrementing a counter, but as things ramp up and your account executives go out and cook up all different ways to finesse how they want to charge that client, it gets really complicated. You add in things like committed spend, credits, you want to automate it, you want to cut people off when they're not paying. The complexity really compounds just immediately. And one of the founders got worked on the billing at Dropbox and had also encountered issues where when you build this internally, which is where everyone kind of starts, it gets very easy to build the brittle system by accident. Build to your local maxima, fits your current pricing and packaging. And then someone comes in with a new product and suddenly they're delayed. Like they can't launch their product or they can't charge for it for weeks or sometimes months. And so you get led into this spot where, you're delaying launches or just like burning compute because you can't actually charge for it, which feels really silly. And then there's also a frequent, you just accept a lot of slippage because building these systems to be perfectly accurate gets really tricky. And, thankfully there's a lot of foundational pieces such as Kafka exactly once, and strong transactional databases that make this possible to build and have confidence in. But it's very difficult to do this internally and kind of prioritize that degree of rigor. And also if you're building an infrastructure company, let's say you're a database startup, your best engineers are there because they want to work on building a database. They're not actually there because they want to work on billing. And so we also think that, kind of consolidating talent to work on this problem yields a better result. And I think the marriage of the business logic domain, the exact correctness needs, and the overall data scale volumes, we're right place, right time for this AI boom, introduces a lot of very interesting challenges. And well, we're about to talk about one of them.
And you chose Postgres, obviously, right? So
yeah, the Postgres decision preceded both of us by a ways, but I think we're broadly quite happy with it.
Okay, good. So do you know why Postgres was chosen in the past?
Not precisely. I mean, broadly, we immediately went to using RDS. I don't know if it was immediately Aurora. And
interesting.
Yeah, I think it would be an interesting decision as a small startup who anticipates having a lot of data scale to want to deal with the schema change pain associated with MySQL.
Yeah, I wanted to add a joke that maybe somebody Googled some open source relational database with good money data type. But money data type is what people shouldn't use in Postgres.
I think we're mostly in numeric, but at this point we're kind of cursing that we didn't lock down the precision more tightly because Postgres will give you far too much precision, and kind of having that interoperate with any other system becomes difficult, and so we're starting to figure out how to unwind some of those decisions.
Yeah.
That is an interesting tangent, especially I guess with people billing by fractions of a cent and things. So yeah, Anyway, probably too much of
Yeah.
a tangent, or maybe we'll come back to it later.
Yeah, I mean, in short, yeah, it gets very painful translating between the different systems that do or don't have that precision. And sometimes even your billing provider, understandably can't bill in fractions of a cent, which
Yeah,
means that how all the different, sub products you paid for and how those round together, might not end up with the same total.
yeah.
Yeah. Can you tell us a little bit about the scale? I remember 30 terabytes on Aurora from the blog post. Anything like in this area you could share to get us the feeling of the scale?
So we have two primary workloads that are running on Postgres. The one we'll mostly be talking about is our, like main DB, which is, a common startup pattern. We've got our kitchen sink database that has nearly every data set within it. And yeah, that's ballooned out to around 30 terabytes now and growing terabyte plus per month at this point. And yeah, wasn't an issue for a while. And then depending on how our clients leverage our platform, part of billing is generating invoices, and invoices are usually characterized, with like, thoughtful total and whatnot. But then you have a line item per product usage. And, some of these companies have a lot of different products you can pay for. You look at the list of different LLM, model engines that are available. Sometimes you can use batch, async versus real time, or like infrastructure vendors who are, deployed to dozens of different regions. And it's easy for the cardinality here to explode, especially if you want to group it by like a logical application on their platform. And we made what we now regret decision to basically persist those line items as a separate row and a ginormous table in our Postgres database.
How big is that table?
It's about half the cluster and growing.
Like 15 terabytes unpartitioned, right?
Yep.
Yeah. Yeah. Well, I know this.
Yeah.
It's a pain. It's a pain. Yeah. Yeah.
Yeah. There's some scaling problems you get really ahead of, and others that you defer because a lot of the technology in the Postgres space is really fantastic now. Like
Yeah.
Aurora, does broadly just handle it. Caveat making sure that you're dealing with vacuuming and whatnot, and all the other kind of implicit thresholds.
Actually, I forgot to mention it's those who watch Postgres FM regularly should watch already by this point previous episode with Sugu and where we discussed multigress and sharding, and in that very episode he mentioned your case, right? So yeah, I wanted to answer this is what we go to do next week, but it was a secret at that time. So yeah, and before that we also had PGDoc, Lev Kokotov from PGDoc, and obviously sharding currently is hot topic again, and there's Citus in the past, there's SPQR. Before that we had a PL proxy from Skype very long ago, like previous era. So is it right to say that the problem we are going to discuss today, you wouldn't meet it if you were on sharding schema, right? If your database was sharded, this wouldn't happen probably.
I think we've seen behavior, suggest that it would be easier to avoid it. As part of the migration that we're about to mention, we're moving another table that's generated data to a like partition scheme. And we've already seen a lot of positive effects there, and that, you can run a lot of auto vacuum workers in parallel. And so it kind of allows you to, much more easily keep up with the rate of change.
This is partitioning, not sharding. And with unpartitioned table, the problem is vacuum is single-threaded, right? So with partitioned schema, you can raise a number of workers for auto vacuum max workers. You can raise it and benefit from it if you have a lot of CPUs and disk I/O capacity. But what I'm trying to say, problems like these, they can be avoided completely if we have sharding and every shard is smaller, every single shard is smaller.
And that's what I was trying to get at with, by partitioning it, we can kind of see the effect of, if these were all in logical chunks that were, maybe at max 100 gigabytes, it's much easier for the garbage collection system to keep up.
Yeah. That's interesting.
It would be even easier if we were, across many machines. But at the very least, I think we can infer most of the effect, even if it's all on one.
Yeah. Okay, maybe it's already time to dive into the problem itself, right?
Yeah, or maybe briefly, why we create the problem.
Yeah, before you go into that space, I was curious, do you have any issues with MultiXact's before that at all? Like maybe other kinds of issues like observing in performance insights, lightweight logs, contention, lightweight MultiXact, or like there are a couple of them. You never had them before, right?
None in particular. No, I mean, we had run into, emergency auto vacuums for sure.
Yeah, that's very interesting because your path is, definitely is different from what we observed with other projects. Because usually different problems with MultiXacts came and contention happened and so on. Your path is quite unique in this case, I think. Yeah. So let's dive in.
Yeah, I really want to describe how we create the problem for ourselves, and I really want Andrew to explain how we diagnose it, 'cause that's the most interesting part here by far. Yeah. As we keep seeing these tables grow, we kind of realize also due to some access patterns that were introduced, it wasn't really tenable to keep just appending data month after month for every customer in terms of the line item table. And, this was also painful for the invoice table, which, there's a lot of write amplification between the two. The average invoice has, dozens and sometimes hundreds of line items, depending on how a client's using our platform. And so invoices have to be queried a lot of different ways. We didn't really see a way of moving that outside of a relational store and being able to use foreign keys and constraints with it in the rest of our data. It was providing too much value to really doing anything different there. We did wind up partitioning it just to enable the auto vacuum process to keep up much more easily. But we realized that we could constrain the access pattern for the line items sufficiently that it didn't actually need to be in Postgres. Because I guess within Metronome, over the course of a month, you have the notion of an invoice that's in a draft state where we'll calculate on demand for you, but we're not actually persisting data associated with it. Then only after you go through a finalization, which is typically the first of the month, because most billing periods are going to be monthly, that we do all the math, do the calculations to persist that data, which, you can then infer our workload sounds pretty funky. So we've got a steady trickle of writes for configuration changes. And then once a month, we have to write out several billion rows, which, amounts to 1 to 2 terabytes of data.
Yeah.
All on the same day.
As close to it as we can get.
Yeah.
Very different from social media. Very different.
And otherwise, it's, a more typical, we have 99+% reads versus writes. A lot of this is, compute on demand. So it's a little funky. I think that because the high spikes in write volume are so periodic is why we hadn't seen multi-exact problems in the past. I think we'd likely narrowly been avoiding them because it's so hard to observe whether or not you're approaching them. I feel like this is one of the meta-stable states of Postgres. If you're familiar with that page from the definition of meta-stable, where often things are working, and they just fall off a cliff or entirely lock up. But the basic trigger here being, we identified we wanted to make this architecture change, and then we were running the very long migration process of pushing these line items into S3, which is what our backend store was going to be, since our access pattern was so simple, but also rewriting and moving the invoices from one table to another. And unfortunately, we're doing that broadly one by one, which we'll get to why that's relevant.
So you mentioned performance cliff. This is a very good term when we talk about multi-exacts, and we had different cases in the past where, as I mentioned, contention happened. And interesting enough, we always, 20, 15, 10 years ago, we often saw opinions that foreign keys are dangerous, they have huge overhead, don't use them because they slow down everything and so on. But interesting that now we can agree with it, but in a very different way, in an unexpected way, because they slow down writes, but we can afford it. And your table, which grown to 15 terabytes, is a good example, right? You survived with foreign keys, and you paid that price to have good data consistency, right? But then performance cliffs, right? So
I mean, for that table in particular, the reason why we were able to move it out was, it only had one foreign key, which was back to the invoice row. It was much simpler. That table is effectively append only.
Mm-hmm.
And so it was a workload that just really didn't have to be on Postgres. I don't think we were taking advantage of the qualities to justify the cost.
Mm-hmm. So let's discuss multi-exacts in general, why we should think about them. My own story is usually with multi-exacts. I take some monitoring. This is my hobby. Take some Postgres monitoring, and we check which metrics they have. And usually they have transaction wraparound risk analysis, right? Like to control freezing process and to understand how far we are from transaction ID wraparound. And my question number one: where is MultiXact ID wraparound analysis? Most monitoring systems lack it, but they lack it because it never happens. Usually, like transaction ID wraparound happens, we know several blog posts and horror stories from the past, but MultiXact ID wraparound nobody experienced it, right? So, okay, why should we think about MultiXacts? Like, tell us more technical details. What happened with your case?
Well, briefly, I'll respond to the point about, foreign keys is, I think the community is right in that you don't always need them. But I think what can be tricky is that, when you're a very young company making lots of changes to your product, trying to find that product market fit and get to the point where scaling becomes the biggest concern. Foreign keys are really useful to like prevent teams from stepping on each other and breaking your data. And only when those product areas and like the platform you're building on top of become mature enough, can you maybe afford to put in the, like pull request level, integrity checks that make sure you're not changing some access pattern, or maybe build the asynchronous, like offline data consistency check to make sure you're not violating it. And like, this is a case where we didn't think critically about have we made that leap from one side to the other. And, in retrospect, we have, and it's one of the mitigations we took.
Yeah.
Where,
So,
I guess like I would defend having a really strict schema early on. And then
yeah,
as you scale the
yeah.
platform, it just becomes necessary to forgo some of those guardrails.
Yeah, to maintain good quality of data, that's absolutely great advice. But let's discuss how multi-exact are created, like, and so on.
Sure. Yeah, so I suppose we should start with what a multi-exact even is and when it's used. So basically in Postgres, when you have two or more transactions trying to lock the same row at the same time, for instance, when you're using select for share or select for update, or in fact, when you're inserting into a table that has a foreign key to another table, Postgres uses a system called multi-exacts or multi-transactions. And a multi-exact is basically a logical object that represents a set of transactions locking the same row. Each participating transaction is called a multi-exact member, and those are a little distinct, but they are related. And the way that a multi-exact is stored is that it's represented by a 32-bit integer ID, and that's where your wraparound issue can happen with multi-exact IDs. But in this scenario, that was actually not the problem. For every multi-exact, Postgres keeps an offset into a globally shared append-only multi-exact membership space. These are stored in the pg multi-exact/members file on disk. You can think of it as logically like a simple last recently used cache that is contiguous, so you have to append to it every single time. And so when you have to store these members, you will have to look up an offset into this theoretically long array, and each one of your transaction IDs is stored in one slot in this array, and this array is indexed by a 32-bit integer. This membership array is what it was exhausted in our case. So due to the way that multi-exacts are created and subsequently reaped, it is easy to exhaust this membership space when you have a lot of parallel transactions attempting to lock the same row, whether it's through foreign keys or whether you're doing select for share or select for update. And the reason for that is that since these multi-exacts are immutable, suppose that you have three transactions trying to lock the same row. You would first create the first multi-exact between the first two transactions, and then the third transaction would come in and you have to create yet another multi-exact with the old transaction IDs and then the new one. But the membership space is not relinquished until a vacuum occurs, which can happen later or perhaps never in some cases if you are constantly adding new transactions and you're super busy doing all these updates. And what's interesting is this. The multi-transaction membership space cannot be reclaimed in chunks. It has to be reclaimed contiguously. So suppose you have a very long-running transaction that is part of a multi-exact that is very old. It can hold up the entire vacuuming of subsequent multi-exacts that are finished, but are short-lived. And it is not until that the oldest multi-transaction is finished that the vacuum can actually reclaim all the membership space from the old MultiXact to the most recent one. And this scenario creates the ability to exhaust the MultiXact membership space. And that's what we experienced ourselves.
Yeah, I wanted to add one thing. It might sound strange that select for update also may produce. You also explored this, right? It happens only when we have sub-transactions, I think, right? So if like it's a single transaction, select for update, like there is no place for multi-exacts. But if we start doing save points there, basically we have different transactions inside one transaction, and then multi-exact mechanism starts working again. And I just remember, like, how many years ago? 4 years ago, I explored this when I explored another big performance cliff related to sub-transactions. So there I noticed this as well, yeah.
That is true.
Good introduction, thank you so much. So, yeah, it's not it, right? There's also some problems like quadratic behavior, right?
Yes, I hinted at that before. So essentially, if you have, let's say, 5 transactions that are attempting to lock the same row, you have to create the multi-exacs one at a time by essentially cloning it with the previous transaction IDs and adding that additional transaction ID one at a time. So now you have a multi-exac with 2, then 3, then 4, then 5. And you add that all up, and that becomes a quadratically growing use case of multi-exac membership space, at least until the vacuum can actually clean up those old multi-exacs. And so that's where you will find quadratic consumption of the multi-exac space, and this can happen very quickly if you have a lot of concurrent transactions attempting to, say, insert into a table with a foreign key that links to another table that is a low cardinality table. So they're all trying to reference that exact same row.
But it's also applicable when we have also additional long-running transaction, right? Because otherwise cleanup will happen, right?
Correct. So a long-running transaction will cause the vacuum to essentially stop reclaiming multi-exact membership space until it is finished, because it can only do it sequentially.
Yeah. Is it this transaction, long-running transaction, should it also participate in multi-exact mechanism, or it can be any, even simple select?
A simple select probably won't do it. It would have to be in a multi-transaction context. So if you, let's say, have a multi-exact and you have 2 transactions in that, and the first one finishes, that multi-exact is not cleaned up until that second transaction. Part of that multi-exact is also finished. So all transactions in the multi-exact have to finish before the vacuum can reclaim it.
Yeah, so this highlights like pieces of advice, like partition your large tables, avoid long-running transactions if in Postgres or OLTP, right? Like just yet another reason to avoid long-running transactions. And if it's, so long-running transactions on replica reported by hosted by feedback, they are harmless here. So, right? So, like, again, we are debating right now how to properly monitor long-running transactions, because there are different effects, negative effects, and we need to distinguish them. In this case, we should monitor probably long-running transactions which participate. So, yeah. And by long, how much long was it in your case? Like 1 minute is long, or 30 minutes is long in this case?
I'm actually not sure. I don't actually have the metrics on that. Nate, do you know?
I think 99.9, probably 9% of our queries are sub-second. And I guess like I previously worked on a database infra company or infra team at Stripe, and like had some of these lessons just like really deeply or have all the scar tissue, in short. Because running a platform at their scale is difficult. And so I've been pushing us in that direction and kind of moving anything that we expect to be longer off of the online workload into our lakehouse. And so it's very, occasionally we have queries that go 5-10 seconds, but I believe we have a global timeout of about 30 seconds. So I guess like part of my misunderstanding here is I thought part of these multi-exacts is that the multi-transaction can be daisy chained as you have many concurrent overlapping transactions occur. I think that's more what you're running into than like a long running one.
Mm-hmm.
Was that we just have this steady stream of overlapping transactions. And like until you break that chain, you're in this like hose position where you keep very quickly at an increasing rate consuming space.
Yes, I was only merely stating the cleanup scenario and the challenges there, but you're absolutely correct. When you have this daisy chaining, constantly creating new multi-exacs by adding new transaction IDs to it, you will very quickly exhaust your membership space.
You say very quickly and very easily, but I mean, we are still talking about 2 billion, right? And I think there's been a debate in the Postgres world about 32-bit versus 64-bit for a long time, but we are still talking about 2 billion. So you say very quickly and very easily at your scale, right? This is also due to how many things you're doing, and maybe the pattern as well, like invoices that have lots of line items, or it feels like there are specifics here that make this more likely. I'm not saying it shouldn't be a problem. I'm looking forward to hearing how you diagnose this and what we can do better. But I feel like we should say it's not necessarily very easy to hit this limit. I think I found one other Stack Overflow post of somebody else who hit it. I don't know if you came across that while you were in the middle of this, but I couldn't find any other examples on the mailing list. But it's super interesting, and I think we're seeing more and more companies using Postgres at this scale. Like Nikolay mentioned a few of them that we talked to, but we also had an episode with folks from Notion and Figma and Adyen as well on that same episode. So there are a lot of high volume companies now on Postgres. So I think this stuff's super interesting. But 2 billion still seems like, even with the daisy chaining, it still seems like a lot to me.
Let me disagree with you. There is no, debate is not 64 or 32. Postgres desperately needs 64 transactions. And for example, AureoleDB already implemented it. Right, so AureoleDB is alternative storage engine, and it's right now in hands of Supabase in terms of development. And I think right now there is launch week, and they publish some benchmarks again. It's great project. So I think many projects dream about the day when we will have 64, not 32. Right now, only several forks implemented only. Right, there are commercial forks which implement 64 transaction IDs and multi-exact IDs. Right? So
I didn't know that.
Yeah.
Sadly, not Aurora, it sounds like.
Yeah. Yeah. So 2 billion is not it's not a lot already. It's not a lot.
Yeah. It's pretty easy to hit it if you're going at scale and you're hitting it with quadratic velocity.
Oh, yes.
You get to 2 billion quickly. It does sound like a big number, but
yeah. But Michael, sorry for interruption. Michael, you can take a chessboard and start putting one grain on first cell and so on.
Yeah. So wait, maybe I misunderstood. If there are 5 row changes we're trying to do we create 2 to the 5 rows in this table, or is it 1 then 2 then 3? Is it only 5 rows? In the member space.
Yeah, good question. So basically, it's more of a sequencing thing. So essentially, you say you have 2 transactions. You start with 2. You get one multi-exact taking up 2 members.
Yeah.
The third transaction comes in. You create a new multi-exact with 3 members, but that old one with the 2 members has not been cleaned up yet. So you're taking up 5. The third one comes in. The fourth transaction comes in. You create a multi-exact with 4 and 3 and 2. So now you've added an additional 4 on top of that. And now the 5th one comes in, and now you have a multi-exact with 5, 4, 3, 2. And that all added together takes up membership space until the vacuum can come up and reap those old multi-exacts.
Yeah, chessboard example is good here, I guess. We can try to understand volume when we approach 64 cell, number 64, how big it will be.
And you've done such a good job describing how this could happen, but when you're in the middle of this, I'm guessing this is relatively new knowledge, or when you're in the middle of this, how did you work out what on earth was going on?
Yes, that's quite the journey. So I'm actually really new to Metronome. I just joined in April, so when this incident was occurring, it was only my 5th week or so, and this was occurring on a Saturday right before a vacation to Miami. So
Wow.
Well, but let's rewind a little bit, because I guess the most embarrassing part of this is what we now know was the first occurrence was a full week prior.
Yes.
Where our migration workload had basically implicitly triggered this. We hadn't really known what to do. And unfortunately, we're not able to get to a full RCA. And so, we got to our best explanation, which is there's something in transaction ID wraparounds that we're not grokking correctly or Amazon's hiding something from us. And then we proceed to turn it back on with a slightly lower concurrency, 5 days later. And so so we didn't get there immediately, but then, that was a P1 incident, internally tried to be cautious, but didn't follow through sufficiently. And so this is like kind of in the second chapter where Andrew comes in.
Yes, that's right. I was not a participant in the first three incidences. It was only the fourth one, which I think was on a Saturday, in which the call went out from Cosmo to see if additional engineering resources could come and jump on. So I decided to, but having been so new, I actually didn't have any tactical knowledge I could use to address all the specific fires that were being started by this. So I decided to actually figure out what exactly was happening. And as Nate had said, we weren't really sure, but we knew it was related to MultiXact in some way. We just weren't really sure exactly why. And we were struggling to really fully understand, because in our initial evaluation, we saw that the number of MultiXact IDs that was being created was well below the threshold of like 400 million. And we weren't really sure why. So what I did is I took that knowledge and I just went ahead and looked into the Postgres source code and looked at the multiexact.c file, which is this enormous file that contains pretty much all the logic that you'll need to know about multi-exacs. And in there, we were working with the hypothesis that somehow this threshold of about 400 million, but we were only seeing 200 million before vacuums started occurring, was related in some way. So I found the function called multi-exact member freeze threshold, which calculates the threshold that you should start basically an auto vacuum based on the number of multi-exacts that are in use and newly the number of multi-exact members that are in use. And that's what caught my eye. So from there, I mathematically proved that the amount of members should be extremely high given the code path that we are obviously hitting, because we're seeing vacuums occur at a specific number of multi-exacts being used. And from there, I was able to find log messages related to multi-exact membership exhaustion and correlate that with Datadog logs that we had found ourselves in the recent week. And there we could conclude that multi-exact members the membership space was being exhausted. And we were able to put together what I would consider kind of a hacky estimate of the number of multi-exact members that are currently in use by looking at the files that are written for each member and estimating by multiplying by a constant how many members are currently in use at the moment. And that's how we came across the solution, or the cause, I should say.
I think this is worth diving into a little bit, because I definitely didn't realize that there were at least two exhaustion possibilities with multi-exact. So we've got the total. Well, yeah. So why are there these two numbers? Like, why do we have two? There's 2 billion that you were monitoring at 400 million, which should be super safe, right? Because we have the possibility to go up to 2 billion, but you want it to be cleaning up much sooner than that. So you monitored at 400 million or so. Why is there another limit?
Yeah, so we have two limits here. We have an ID that we give to multi-exacts. That's a 32-bit integer. So of course you cannot assign more than 2 billion to these multi-exacts because we don't assign negative IDs. And then you have the multi-exact membership space. Now that is represented as logically a simple LRU that is append only. And so we can only address up to 32 bits of membership space. Each membership slot is addressed by a 32-bit integer. And thus now you have two different values that you have to worry about. You have to worry about how many multi-exacts you're creating and how much membership space you're consuming with those multi-exacts. And that's where those two numbers come from.
And one of the great things in your blog post you mention is, how do you even monitor that? Right? Have you worked out a way since? Is there anything you can do there?
Yes, I think I might have just offhand mentioned it, but we use an estimate where we read the membership files because they are written to disk, and then we know that the files have to be a certain size, and we multiply by that constant, whatever the size of these members are, and we get an estimate for the number of members. Now, this is not the best solution, which is why I submitted a Postgres patch to surface this telemetry directly.
Nice, thank you.
Yeah, that's what I wanted to mention. We have several things going on in mailing lists after this blog post. By the way, before this, why did you decide to post in so great detail? Like, what was your intention? To help community or like?
I think it's a couple of factors. I think one, we do want to help the greater Postgres community. I think there have been lots of other situations where we've benefited greatly by blog posts put out, in particular by companies like Bracona, as well as others who, maybe led us away from paths that would have wound up being painful. But another part is that, internally at Metronome, we view ourselves as a infrastructure provider for our clients. And while, I think it's okay to say that we're not fully recognized as that yet, and we're still on our journey to solidifying that narrative. It is what we want to, or how we want to act to be perceived that way. And we are in the critical path for a lot of our clients and how they operate. And so for us to have multiple, multi-hour downtimes in the space of, less than 10 days is like pretty bad and honestly not what you want from your infrastructure provider if you choose to view it that way. And so having a really crisp explanation of, hey, we are a little embarrassed by this, but like, here's what we learned so you can learn from it, as well as a little bit of vetting of like, we didn't run into the easiest thing. Yeah, it is novel. There's a reason why it took a while for us to sort it out. And so I think a lot of our partners felt a lot better. I mean, better could be a strong term, but I think when you have an honest RCA and like, Cloudflare might be like leading the industry and like how they operate in this vein, you feel a lot better that your provider is actually learning from mistakes and is going to do a better job of avoiding them than you might internally if you're evaluating should I just build this in-house instead.
So great transparency and so on, it pays off over time. Yeah, that's great. So I saw several mailing list discussions, but before that I feel like with MultiXact we can have different kinds of problems. One is wraparound, right? Okay, as I said, I never saw it, and that's why many monitoring systems don't monitor it. And we have several cases of SLRU limits reached, right? And one of them was explored in the past. We can provide maybe blog posts, links to description. And this is your case. And your case obviously bumped into lack of observability bits, like how much of capacity we reach, like how far from the performance cliff we are, right? But also besides that, I saw different topics were discussed in mailing lists. For example, there is a setting vacuum MultiXact failsafe H, which is about wraparound actually, right? And Peter Gagan brought to attention that this setting doesn't take into account MultiXact membership exhaustion. So it's also interesting side effect from your blog post, maybe fully unexpected, right? Then I saw Andrew, yours proposal to have restart MultiXact monitoring, like system view, so any monitoring could have some graphs and also alerts probably, right? And this proposal currently at what stage? I saw it's in commit fast, but it requires review, right?
Correct, yes. The patch is in the commit fest, and it definitely still requires review. I've engaged with another contributor named Naga, we've actually submitted competing proposals. His actually directly reads from the memory space, while mine uses the PG stats infrastructure to surface this telemetry. But yes, it is still just in review. It has not been accepted yet as far as I can tell.
Yeah, but it's great that it's registered in Commit Fest, and I think if some people who listen to us and maybe some people who watch also our sessions of hacking we do with Andrei and Kirk sometimes, almost every week. We missed today because of some issues, but we are going to be back next week. So we show how easy it is actually to test. You take cursor, you tell it just compile Postgres, apply patch, and let's start using it. And just you instead of diving too much into C code, you think about use cases and how to, for example, emulate problems, right, and so on. This is actually fun, and I encourage our audience to maybe to start with their first review and test this patch, and this can increase chances that it will be included to Postgres 19, right?
Yes. What's also kind of interesting is I know you earlier mentioned that there was a debate about moving to 64-bit integers, and in fact, part of this commit fest does include a proposal to change those offsets to 64 bits. So there's a lot of changes that are coming in 19, it seems, if they're accepted, of course, which would help alleviate this multi-exact membership and multi-exact issue writ large.
That's great, but it's only next year in terms of...
I suppose we can't go too fast.
Yeah.
Well, and even longer if it's Aurora, right? They have generally a bit of an additional lag to getting major versions because it's a fork that they have to do a lot of work on. On that note, though, you mentioned kind of trust in an infrastructure provider and how big issues can rock that trust, and you kind of need to see some maybe root cause analysis or maybe some action. Has this at any point rocked your confidence in Postgres, or less so Aurora, I guess, in terms of is it the right platform as you scale? Like maybe initially, and then since you've worked out exactly what the issue was, what are your thoughts there?
Yeah, I don't think it actually has really rocked our confidence in Postgres. I haven't seen anyone run for the hills yet, but it definitely surfaces the fact that there is quite a bit to learn and that this is a very complex system. But to that end, something I've learned, at least participating with the Postgres dev community and being on the mailing list, is that there's a lot of very smart individuals who are part of this community and who are actively contributing and are passionately debating what should and shouldn't be part of it and how things should be designed. So in many ways, it actually may have built my confidence to see so many people paying attention and caring about it from all across the world, from Fujitsu, Amazon, Google, ourselves, even just regular folks doing it in their hobby spare time. So in many ways, perhaps it's a testament to how far open source can go and how much confidence we can have in these systems, because like you said, this is a pretty rare instance, and many of the core cases that most people need to use are covered, or at least will be.
That's really good to hear. And of course, when people hit issues with proprietary systems like SQL Server and Oracle, I'm sure when they blog about it, those conversations do happen internally at Microsoft or Oracle, but you can't see them. You can't see the actual conversations. And part of the way you diagnosed this issue was diving into the source code. So there are some really cool factors that wouldn't have been possible if this wasn't open source. So yeah, or not just open source, but open discussions as well, open mailing lists. So yeah, that's really good to hear, but it would have been very understandable if people have definitely left Postgres for less good reasons. So not naming names, Uber.
Yeah, I will say, as we said in our blog post, 30 terabytes is not a small amount of data to move. And so if we decided to make a large decision like that, I believe we would have to reckon with the transition itself. And so in many ways, we probably want to try to work with what we got. And thankfully, I think it's served us well for the most part.
Yeah, there's something to be said for the devil you know. And, there's lots of other systems, Postgres compatible, that promise you the world, and something gives typically, whether it's the price, the actual performance on either the read or the writes, or how maintainable it is to actually run it. And I think it's clear that we're going to have to undergo the investment to figure out what's next, because we can only go single writer for so long, especially with the demands that we put on the database on the first of the month every single month. They're pretty extreme.
Yeah. And behind the scenes, we also chatted with Nate about the formula. So, Michael, for the first time, we should include some formula in the show notes. There's a formula that it's saying that roughly 63,000 transactions overlapping is enough to reach 2 billion limit.
Yeah, right? and so we're doing a dangerous thing with some math on the fly that can be checked by anyone after the fact. But yeah, as I worked it out, yeah, only 63,000 overlapping transactions, which is not that many. Relatively easy to do depending on how with a highly concurrent workload operating one row at a time with a potential of overlap between them, you can consume that really quickly.
It might not also be transactions. If you take a checkpoint, that's almost seen as like a sub-transaction and will also create a new MultiXact as well. So if you're doing a lot of checkpointing, you can easily hit that as well.
Are you using sub-transactions?
I'm not actually sure myself, but it is a possibility.
Yeah, I don't believe we are, or at least not intentionally.
I think right now in the latest versions of Postgres, there's ability to change SRU sizes to avoid SRU overflow cases. But my opinion about subtransactions in projects like this, at this scale, remains just avoid them. Yeah, because they can bring other problems as well. Like subtrans SRU can be overflown and so on. Yeah, and they consume transaction ID. So, yeah. Good. That's I think quite good deep dive. Unless we forgot anything.
Any last things you wanted to add?
I think we could talk through the mitigations just so that if someone's unfortunate enough to run into this, that
Oh yes, that's a good point.
they have a few breadcrumbs for how to work around it. Because it was rather expensive for us to figure out what those were, including Andrew and others digging through the source to really understand it. But a lot of what we inferred after the fact was, so we had this migration, which was doing a bunch of row by row writes. Not ideal if you're doing a highly concurrent process here. And so we did make those batches. We also did a lot of deep thinking on which of the foreign keys we actually needed on this new table.
Sorry, batches. How did you find the ideal for you batch size?
I don't know that we're at an ideal, but I think we climbed the hill far enough that it's not a problem.
I see.
And so it was kind of a trade-off between what throughput we could obtain and making sure that we weren't having the kind of like over time growth in our like heuristic for the member space utilization, which is mainly based on how many of the offset files existed.
Yeah,
What kind of order of magnitude? Oh, sorry, go on.
Yeah, I usually say choosing batches, choose the biggest possible, but avoid locking rows for too long to affect users, because users, we know perception is 200 milliseconds, so if you lock like 1 second should be maximum, maybe 2 seconds should be absolute maximum for batch size choice.
Yeah, it's less often. So if we were doing batches around like 200,
Nice.
which was
Yeah.
enough to mitigate this concern and kind of keep all the operations short, since there's a very online workload hitting this as well.
This is not users in terms of batch transactions, but users read results, right? Or no? Nobody's.
No, no.
Okay.
So sorry, this is in the context of our greater migration to move line items,
Yeah.
the line item construct out of our database, as well as partitioning the invoice table, which has also grown to be quite large. And so,
Okay.
we would read the old version, all the line items in the invoice row, write those to a new format in S3, which ultimately keyed by the invoice ID, and then a lot of logic to kind of like we can't just do a deterministic mapping because then you get hot partitions in S3, so you have to do a little bit of extra work and leave yourself a link in the actual database row. And so then we were writing those out to the new table, which is partitioned one by one. And our diagnosis, and it's a little hard to confirm this because again, there is no like observability bit here, was that was the kind of like the big mistake, as well as the single inserts, like very quick. It was the issue that they all reference a handful of other tables for foreign keys, some of which were very low cardinality. So, we have like some enum tables, and we, for better or for worse, in this case worse, had chosen to use a foreign key reference to them. And so if every invoice is, corresponding to, like the USD credit type, for example, you're going to have a lot of overlapping transactions all accessing that row to verify the integrity of the data. And so we kind of walked through it and we realized, a lot of these low cardinality cases, we don't really change those code paths. We're quite confident they're going to be stable. It's only the higher cardinality cases where like, an invoice also references its customer that owns that invoice. But that's a much higher cardinality connection. And we're much less likely to have overlapping transactions referring to the same customer in a migration like this.
Without foreign keys, did you think about periodical checks of referential integrity, like asynchronously?
Yeah, so we're going to be adding those to run our lakehouse.
Okay.
So like we have a syncing process that brings all the files over into Parquet. Eventually we're going to finish the swing on getting it to be CDC, so it's a bit more incremental, hopefully using Iceberg. But
Okay.
and so on those we'll run, it's much cheaper to run the checks there for a lot of reasons.
More and more reasons to move data out of Postgres. I understand it for analytical reasons, but yesterday, and keep it in S3. Yesterday, S3 released vector index. If you haven't heard it, it's interesting. So I'm just curious where the place for Postgres will be in our systems, But I totally understand. For analytical workloads, definitely. So
Yeah. I mean, everything that's OLTP shaped is going to be staying in Postgres for some time. Can't see a reason to move it anywhere else.
well, yeah.
Great. In terms of mitigations, did you tune any of the settings around multi-exact parameters? Yeah. What did you do? Which ones did you increase or decrease?
I don't know if there was actually any specific like Postgres like flags that we changed. Actually, I don't think we changed any constants specifically. But what we did do is we did introspect into the code base and determine the danger levels for membership spaces. And so we use that as a threshold for alerting ourselves with Grafana. And so if our membership space consumption breaches a certain level, what we will do is we will take actions to reduce the number of concurrency, or the amount of concurrent transactions that are occurring until Postgres can recover that membership space. So it's a little bit of a manual intervention at the moment, but I don't think there's any specific knobs that we can tune because it is fundamentally limited by a 32-bit integer. And the telemetry with respect to multi-exact membership numbers is not used anywhere else except in the detection of when auto vacuum should occur, and that is sort of automatic, so and kind of hard-coded.
Yeah, and current utilization, you use function pg get multi-exact members, right? Or how do you?
No, I don't believe that is it. I think it's some specialized function where we actually have to get all the files and read the file sizes themselves. So it's not something from Postgres, I don't believe.
But it's Aurora. You don't have access to files.
There is some function. I can't remember, Nate, if
GLS or something, right? So it lists files. You can. It's still SQL. You can list. Okay, interesting.
The query originated from Amazon blog posts, but I'll try to pull it up. You can see if you want to include it in the show notes.
Let's make sure. I don't remember this recipe was shared in your blog post, how to monitor this. Right?
It was not. We did not post it there. We actually intend to have a follow-up with a more engineering-based audience where we would detail these steps kind of in the same way that we detailed it here, but in a more concrete format for engineers and not for executives and company leaders.
Yeah, and we were a bit more timeline constrained for initial RCA. And we were optimistic that we can link to Andrew's patch for the second follow-up blog post.
Okay,
exactly.
Great. That's awesome because people probably we should add it to monitoring proactively everywhere in large systems, right? This should be main outcome of this discussion probably, right? For those who listen and have big systems.
Absolutely.
Before your patch, Andrew, got accepted and everyone upgraded to Postgres 19, which will take some time, right? So.
Yes, until then, we definitely have some guidance for monitoring systems. We admit, though, that it is not the most ideal, but it is something that people can use to guide themselves away from disaster. So.
Well, and I think there's the thread you mentioned from Peter Gagan. He's somebody that has worked in the past on mitigation factors. So not only to be able to monitor transaction ID wraparound, but he did some things to vacuum so that it's just less likely to get into that state in the first place. And I think making that parameter he mentioned aware of the member space, or have some different parameter that kicks in and does an anti-wraparound vacuum or whatever the equivalent would need to be earlier, would make this less likely to happen. And of course, monitoring is a good idea anyway, but prevention seems even better. So yeah,
optimization inside Postgres could be implemented here because this quadratic behavior, at least it could, as in other cases in Postgres, at least it could be split to some pieces, like 128 pieces, something like this. Yeah. I don't know, I haven't seen discussion of actual optimization to get more capacity. Have you seen it? I'm sure.
No, but I was looking through what parameters we even have that mention multi-exact, and one of them is in version 17. We got multi-exact member buffers, which is quite low by default, only 256 kilobytes or 32 pages, and we got multi-exact offset buffers also low, 128 kilobytes by default. So I'm wondering whether increasing those would help with the member space. Maybe that's the offset buffers one. And then, yeah, we also have MultiXact failsafe age, which you mentioned, version 14. That's the one from Peter Kagan, and two much older ones. I did wonder about freeze min age. That's 5 million by default. I wondered if lowering that would just get you make sure that the vacuum ran quicker when it did need to happen, that kind of thing. And then there's the freeze table age is 150 million. So I'm not sure if lowering that would mean you just get vacuums more often, but I guess when we're talking about such a huge table, it's still going to be a problem with the vacuum does. So until you get partitioning in place. Anyway, thank you so much, both of you. It's been amazing learning about this. Scary, but great. And thank you for paying the pain and the cost so that so many fewer people don't have to in future.
And special thanks for transparency and admitting like your own mistakes in the past. Like I especially appreciate this, like how you talk freely about your own mistakes. This is very valuable and a good example for others as well.
Absolutely. Thanks for having us. It was a pleasure to be here.
Thank you.
Yeah, it's really fun chat.
Thank you and have a great week.